Efficient work depends on the cooperation of various people and the coordination of various processes. In part 3 of 5S Visual Control Systems, we'd like to take a look at shop floor operations. First, what happens when there are no controls?
Oh no, they want to know about today's delivery and the person in charge is off. I don't know where to put the papers. Where are they? What will I tell the customer?
I told you before this machine needed checking. You never listen, do you? All you think about is production, and now we can't produce nothing. Use your head a little, will you?
Oh no, the robot's churning out bad parts. When did it start doing that?
I always said you can never trust machines.
Well, we've probably all experienced situations like that. They clearly demonstrate the time and effort that can be wasted by failing to control work operations properly. In other words, there's no point having wonderful wall charts and explanations if you don't make proper use of them, or if nobody is sure whether or not they're doing the right thing. There are 4 fundamental questions about visual control that should be asked. 1. Is everybody doing what they should be doing? 2. Is the work on schedule? 3. Are there any problems? 4. If there is a problem, what action should be taken? For our first example of visual control of operations, let's take a look at an assembly line in a motorcycle plant. The production indicator board used to indicate simply the total daily target at the top and the present production figure beneath it. So it was impossible to see whether production was on schedule or not until the end of the day's work. The idea implemented here was to display the production target and current production figure in real time. How does this work? Well, an average assembly rate is used to establish the real-time production target. This is input so that the board always indicates whether work is proceeding on schedule or not.
When we only used a simple daily target figure, it really was difficult for supervisors and workers alike to get an idea of the production speed of the line, and we had to wait to the end of a shift to find out whether work was proceeding at a suitable rate. So we came up with this idea of a real-time display, which makes it clear to everyone exactly where the production line should be at any given time, and tells us immediately if any line is really dropping behind. Having a digital display like this has also increased the sense of challenge. Rather than just showing the target for the end of the shift, there's a current target to keep up with. If you think in terms of running a marathon rather than thinking of the whole distance still to be run, which can be very discouraging, you can concentrate on keeping pace with the runner just ahead of you, or, even better, keeping ahead of all the other runners.
This production line board is an interesting example of a real-time visual control which clearly shows both targets and achievements. Our second example concerns visual controls applied to specification charts on an assembly line. Once again, the main purpose is to make the situation understandable to everyone involved. The first feature of these charts is that they use very clear illustrations to explain each work process. The second feature is that important checkpoints are marked with arrows. This makes checking and maintenance procedures much easier and means that even workers not responsible for that process can understand the situation. The third feature is the use of color coding according to type of equipment. This line deals with about 50 different types of engine. To avoid assembly errors, they are classified into 12 basic categories, each with its own color code. The fourth interesting feature is the use of checking seals. Whenever some change is made to a work process or the tools used, the standard specification charts must be revised at the line. Since mistakes can occur, a checking seal is attached to ensure that there is periodic checking of the specification chart so that the information is always accurate and up to date. These specification charts are a good example of applying simple but clear visual controls to point out important checkpoints as well as changes to the process. It doesn't take much effort to set up this kind of system, but the benefits are obvious. This is an aluminum melting pot, where the aluminum melt has to be kept at the correct temperature. It used to be very difficult to determine the actual conditions within the pot, and so they installed this control board, fitted with various lamps and speakers.
We have to be very careful about the temperature and quantity of the hot melt used. If it cools down to a certain level, the lamp flashes and an alarm comes on. We also have warning lamps in the aisles so that action can be taken immediately.
The point here is that a warning is given whenever conditions approach a critical level, so that appropriate procedures can be taken to avoid line stoppages. These warnings are given to both eyes and ears. Finally, let's take a look at an example of visual control that gives a very complete picture of what's going on in the section. This is an equipment maintenance calendar. The top section is a year planning sheet. The vertical columns show the different types of equipment, and the horizontal columns indicate monthly planning targets and achievements. The red magnets indicate that maintenance is planned for that month. The green ones indicate that maintenance is finished. It is therefore possible to see at a glance what maintenance is due to go on when and what has already been completed. Underneath, there is a weekly maintenance planning sheet with pictures of all the workers. This team is divided into 5 groups, 4 of them on the day shift and 1 on the night shift. The cards for daily maintenance indicate the equipment involved and the problem. There are different color cards for each line. Use of these cards means that the maintenance situation can easily be checked by workers on different shifts. Parts required for that shift's maintenance are prepared in advance and stored beneath the cards. This well-designed maintenance calendar clearly shows problem areas, whether work pressure is too great or not, and the current state of the maintenance process. Workers and supervisors alike can grasp the situation at any time, day or night, without having to ask those responsible. Let's review the 3 main points for improving visual control of operations. Point 1. Clarify the work process to make checking of progress easier. This can be done by effective use of maintenance calendars, production indicator boards, and other signs. Point 2. Avoid stoppages by indicating what is normal and what is abnormal. This can be done by using devices to show irregularities, such as warning lamps and speakers. Point 3. Ensure a quick response to irregularities. Devise ways of providing indicators with strong visual appeal. The examples of visual control we've been looking at in Part 3 are concerned with clarifying the whole work process and finding ways of indicating just what the present situation is, what should be achieved, what should be happening, what's going wrong, and what action should be taken. Having cleared up the general operations on the shop floor, let's look next at visual control of the equipment. You may be wondering why we're beginning Part 4 with a fish tank. Not exactly the equipment you would normally expect to find in a factory. But in fact, this is our first example of visual control. What does it do? Well, let's hear from the section foreman why it's there.
It used to be very difficult to check whether the fans for the underground motors were working properly or not, and we began thinking of ways to make the checking easier. At last, we came up with the idea of a goldfish tank. As long as the bubbles are there, we know that the fans are working correctly. This is just one of our 5S TPM activities, but it's proved to be the most popular, and it was a lot of fun to do.
Mechanisation and automation are increasing rapidly in factories all over the world, and they are bringing all kinds of work benefits. However, with fewer and fewer people on the shop floor, it is also becoming more and more difficult to check such equipment. Although many production line operators are expected to check the equipment themselves, many of them have no real engineering experience. As a result, all kinds of problems can occur.
I've found out why the oil pressure unit's leaking. The cooling water valve wasn't opened. As a result, the oil temperature went up. You should have noticed that yourself. Oh, that's right, yeah. Oh, very sorry, sir. Don't say you're sorry. Open it. Oh, the cogwheels are behind the cover. Oh, but they're all cracked and filthy. No wonder the conveyor's stopped.
It is obviously vital that all equipment functions in the way it was designed to operate, and also that performance remains constant at all times. These are the two basic purposes behind effective visual control systems for equipment. This visual device with its dramatic illustration is designed to control the opening and closing of oil valves. We can tell from the arrow on the left that the oil in that pipe flows from top to bottom. Another arrow shows that oil in the pipe on the right flows from bottom to top. And they use green to show that the valve is open. Here is an example of equipment operated by a belt. Before improvements were made, the belt was completely hidden by the cover, and it was impossible to tell whether the belt was correctly aligned and at the right tension. The visual control idea implemented here was to make a window in the cover using transparent plastic. This simple device is used to test the belt tension. White indicates that everything is fine. Red means that adjustments must be made. The label indicates clearly the size of belt in use, its number, and when it should be replaced. Modifications are outlined in red or green so that they can be seen easily. Our fourth example is the use of alignment marks. As you can see, there are many of them all over this equipment, including some very large and striking ones. The problem here is the difficulty of seeing whether deeply indented bolts are correctly aligned or not. By using large marks such as these, abnormalities can be spotted even from a distance. Main control points are marked in dark blue. To indicate the level of cutting fluid. Let's hear now from the foreman in charge of these controls.
We used to have real problems when we did our checking. There were meters and gauges and lubrication points scattered all over the place. So we began to investigate how we could design a better system. It took us a long time to get it right. There were all kinds of problems with the layout, with bad connections, loose joints, oil leakages, and so on. But we kept working at it and ended up with a system that works really well. It's made a big difference to our general efficiency and speed of maintenance, and has also made the shop floor a much nicer place to work. Everyone is so much happier now.
Another effective technique is the use of thermal labels and thermal paints on critical areas of machines which are likely to overheat. In the case of motors, they should be placed near the coil and the bearings. This is the part of a factory which controls the air supply and extraction equipment, which are both vital parts of the painting line process. This is a very large and complicated area of equipment, and there were often problems because some parts were missed during the checking process. The improvement implemented here was to indicate the order of checking clearly. Lines were painted on the floor, a different colour for each production line. Each checking point is marked on the floor as well as on the equipment, using the same colour. The labels indicate the name of the equipment and details of what should be checked. This is a perfect way to avoid checking misses. Let's review the 6 main points for improving visual control of equipment. Point 1. Indicate functional parts clearly for better control and maintenance. For example, with color-coded lubrication labels, valves and pipes, and alignment marks. Point 2. Make temperature abnormalities instantly recognizable by using thermal labels and thermal paints, particularly on motors and pumps. Point 3. Clarify the situation at energy supply points by using ribbons, pinwheels, and other motion indicators. Point 4. Reduce size of covers and use windows, especially where there are moving parts. Point 5. Use colors on gauges to show control limits and indicate abnormalities clearly. Point 6. Make it easy to check if the speed of operation is constant and accurate by the use of speedometers, cycle time indicators, etc. The proper checking and maintenance of equipment becomes ever more vital as production techniques improve and automation speeds up many work processes. We hope we have given you some ideas as to how improvements can be made using better visual control in all parts of the factory. In Volume 3, we will move on to look at how visual control systems relate to production quality and safety measures.